Whew, right off the bat. How about this one, huh? What's the solution? It's got an E in it. Are you kidding me? This is number one. Number one. Here's the good news. You don't need to know how to solve it. Just need to know how to use your calculator. This is a multiple choice question, and I know this sounds dumb coming out of my mouth. The answer is there somewhere, isn't it? Out of those four, the answer is there. So figure out which one works. What do I mean by that? Let's start with 0.583. Is that a possible solution for x that would give me 5,918? Guys, you are going to earn about 8 to 12, and I'm not exaggerating, 8 to 12 points by using your store key on the calculator and testing values out. All right? So let me review, because I know I went at the very beginning of the year. But I'm going to take that first multiple choice possibility of 0.583, and I'm going to type into my calculator 0.583, and I'm going to store that in for my variable of x. And the store key, again, if you guys just missed that, right to the left of the one, right above the on button. And I'm just going to hit enter. It doesn't tell me much, just gives me the number back, which means it's stored in your calculator. And then all I'll do is I'll go back, type in 87, E, and this is a good problem to familiarize yourself where the E button is. It's right above the division sign. Okay. Second division, E, raised to the, was it 0.3? 0.3 x. And your calculator will plug it in for you. You do not need to worry about making a mistake plugging it in yourself. And it says that answer should be about 103 and change, not even close to the 5,918 I needed. So I know it's not choice one. And I keep trying out the other ones. Some of you guys can go right ahead and go ahead of me. So now I'm going to take 1.945 or 54. 45, store that in for x. So that'll override the 0.583. And most of your calculators, what's nice is you don't have to retype that 87.87e to the 0.3x. I think many of you can just go up and highlight that sucker. Down, so you don't have to retype it. Now it'll plug in 0.1945 and not even 5,000 I needed. So I keep checking. And you'll eventually find out of those two which one I'll need. And you'll notice it's going to be hopefully choice 4. Okay? That store key, 8 to 12 points it will get you. Any issues using the store key? Because I have another issue. Okay. As your teacher, I need to prepare you for every single situation that I think may occur in 8 weeks, including what if that's not multiple choice anymore? What if that is a part 2 question where you have to solve for x on your own algebraically? And we're not skipping it. There's no skipping here. Okay, we're not leaving anything blank. So now what I need to go over is, how do you solve that darn thing? All right, let's all pretend it's not multiple. I'm going to do this a lot over the next 8 weeks. And okay, put yourself in this situation. Take away the multiple choices. How do you solve that? Here we go. How do I get x by itself? Let's start with the original problem, 87e to the 0.3x, 5,918 it's equal to. Everything out of there except for x. Everything's got to go except for x. So I don't care if you're right or wrong. I'm just proud of you if you take a leap of faith here. What do you think I could get rid of first? Go ahead. You're going to be right. 87, yeah. I want to get the 87 out of there. You're probably going to be right again. How do you think I get it out of there? Yeah, divide. So go ahead, everyone. Divide both sides by 87. That's the first thing I can get out of there. Divide both sides by 87. So on this left side, I get e raised to the 0.3x. Over here, I go to my calculator. we done with the problem after I do this? I'm asking you this because you're not ready to round yet. Don't get lazy on me either. Write the whole thing out. You don't round a darn thing until the end. Because that's the last thing I need is somebody missing by a point passing because they rounded too early. Or someone missed out on a 100 because they rounded too early. No. I believe. All right. I'll have to go now. Unless somebody knows, that'd be unbelievable. The next. We're going to need to get that exponent here. I can't do much with it when it's up here. I need to get this exponent down there. And you're not going to like this 3-letter word. It is a log. Yes. If you want to get an exponent down. Well, hey, ready? Don't complain. It's going to be there. That's why we're reviewing now. Ready? 0.3x. I want to get it down out of the exponent. Okay, that's great. But you're going to have to log whatever the base is with it. So in this case, log e. And it's unbalanced. What did I just do to the left side? Right? You got to make it balanced. Got to log the number on the other side. So if you ever want to get an exponent down, you got to log the base. All right, now some of you are just freaked out by all the numbers going on, but this isn't too bad anymore now. What do you want to get rid of over here now? The x has to stay. What do you want to get rid of? There's no wrong answer here. Well, actually, if you say the word chair, that's a wrong answer, yes. Yes. What can I get rid of now? I can get rid of 0.3, or I could have gotten rid of what? Log e. Or how about this? Can we do it all at the same time? What can I divide both sides by so I get x all by itself right now? 0.3 and log e. And thank goodness that's where those fraction templates could come into play right now. Use it if you have one. You're going to drive me nuts, some of you. Some kid 5th period. Dude, it's not working out for me. Use your darn template. You get a forearm shiver right underneath the chin. Yeah, it's not working out for you because you're trying to divide it using the division symbol, not your fraction template. Oh, my God. And notice what you're getting out. If you are using it correctly, you're getting out that 14.066. E button. Oh, I should have went over to the log button right here. Right left of the 7 is the log button. And then E again is right above the division symbol. Sorry about that. That's on me. And let me know now. I'll come over and help you if you can't get out that 14.066, which was the final answer. Let me know here as I come around. Oh, we got it. Good. I'm good. Thanks, Grace. So take away from this problem, if you want to get the exponent down, got a log of the base on the other side. Great, thanks. Oh, there's anything else? Yeah, you want one more? Yeah, you'll get one more. And it's not number 2 because number 2 is from the stats unit, which is the next unit. So let's go to number 3 right now. Oh, I got x squared plus 9 and I got x plus 3. Which operation would not result in a polynomial expression? Well, here's the good news. I'm not going to ask you to add, multiply, subtract, and divide all those two. All right? You got to know what this is, a polynomial expression. All right? First thing, it's variables with positive exponents. Okay, variables with positive exponents. And here's the key, and here's what's going to answer this question for you guys. Those variables, you can only add, subtract, or multiply them. Add, subtract, or multiply them. I'm not expecting you guys to write this down, but 3x squared plus 22x, that's a polynomial expression. Why? Positive exponents, and what am I doing to them? Adding and multiplying. Okay, so if you take a look at these choices up here, which one's not going to result in one where I'm either adding, subtracting, or multiplying with positive exponents here? The division one. All right, I can't be dividing. All right. This right here, x squared plus 9 over x plus 3 is no good. Okay, no good. Ooh, ready? Every possible scenario. Remember that. Why would that be a polynomial expression? Dividing, you said that's no good. I'm not done yet. What can I do at the top? And what about the bottom? X plus 3, what can you do? Oh, and what's left? Yeah, that's a polynomial expression. Why not this one? Because can I factor x squared plus 9? No. And you ever pull one of these? No. Don't show up the second semester. Don't. All right. Good. Okay, there's your Algebra 2 reasons review for the day. Do not lose these. Yeah, choice 4. Yeah, the answer is 4. Yeah, it would not work. One job. That's why I circled not at the beginning. Hey, to get you psyched up to come to class tomorrow, synthetic division review. Yeah, buddy, synthetic division. Oh, boy. All right, speaking of units we like, probability. If you have your Chromebook on you, please get it out right now. Everybody, if you have it on you. If not, somebody in your group hopefully will allow you to press enter once. Once you get your Chromebooks open, please go to the website roll-dice-online.com. Yeah, we are getting interactive today. And just leave that front home page there. You guys can pass around your laptops in a second. All right, quick review of last Tuesday. Because probability. Tell me something. All your answers have to be what? Okay, positive. Let's keep going. Expand on that. Never negative, correct? Between 0 and 1. Okay, between 0 and 1. Okay, can't have a probability of 3 halves. That's impossible, right? That's 1.5, between 0 and 1. Good. And there's 2 types of probabilities. There's experimental and there's theoretical. Theoretical is what should happen. So help me answer this question pretty quickly here. What's the theoretical probability of rolling a 4 on a 6-sided die? So what should happen? What's my probability? 1 out of 6. 1 4 out of 6 choices. Yes, 1 out of 6. Now we're going to do an experiment. And based on that experiment, I want you to find the probability you'll roll a 4. Because it may not be 1 out of 6 anymore. All right? So what we're going to do, just so you know, we're going to do it online. But what we're going to do is we're going to roll a die 10 times. And I really didn't feel like hearing all the noises of a die. I don't even have however many people are in here dies. All right? Sorry. So that's why we're going online. All right? And more for the sound than anything. So we're going to go to the old Dice Online. And we're going to tell it to roll 1 die 10 times for us. So already in there should be 6 sides, right? Number of dice to roll, just one. And number of rolls, 10. Okay, and then you're going to hit roll dice. And all the numbers that came up 10 are going to show there. Should be 10 of them total. Don't worry what it says about average. Okay, everyone have 10 numbers there. That showed you what number came up on the die. And what I'd like you to do right now in the columns I have is write in the numbers that showed up. So for me, let's see, I had a 3, 5, 3. First 3 rolls, a 3, a 5, and a 3. All right, please record those and pass your Chromebook to somebody else right now so they can do it afterwards and just hit roll dice again so you get a new set of numbers that comes up. 3, 5, 3, 3, 2, 3. 5, 4, 4, 6. All right, here we go. Now, based on those 10 rolls, what's the probability? And it's going to be different from any. What's the probability of rolling a 4 from this experiment? For me, take a look at mine. For me, it's going to be 2 out of 10 or 1 out of 5 if you want to reduce it. So go ahead right now. Find your experimental probability. Did any group have everyone get the same probability? Everyone, not like you had a match. Everyone. Probably not, right? Huh, okay. How close did your experimental come to your theoretical? Like mine was 1 out of 5. Here you go, watch. You can use your calculator for this. Mine was 1 out of 5, which was about it's just 0.2. And then what should have been is 1 out of 6, which is mine's pretty close. I don't know, any you guys? Pretty close or no? Just on your 10 rolls alone? Yes, no? Trying to hear some discussion here. Here's what I want to do now. I want to take your 10 rolls and my 10 rolls and everyone's 10 rolls and combine them. Do we get any closer to that 1 out of 6? All right, so here's what and I don't need you to do it. All right, I'm going to do it up here. I'm going to make a little, it's called a dot plot. I'm just going to get however many times a 4 came up for you. So I'm going to go around the room real quick, and I want you to tell me how many times, actually 0, 1, 2, 3. I don't think anybody have over 6 times? I didn't think so. So these are, this is how many times the number of 4s came up, and this is that frequency. So for me, what was mine again? I don't even remember. 2, thank you. So all I'm going to do is, oh, shoot, sorry guys. 2, 3, 4, 5, 6, 7. What am I doing? Getting rattled. Okay, so 2 came up for me. Let's go around here. Oh, nice. Oh, big timer. Let's go. Just start spouting them out for me. Okay. I got the 2. Whoa. Okay. Thank you, everybody. All right. So what's the probability now of the class experiment? Ready? Let's see how many times it came up. Ready? Let's see. That's 4, 7. Everyone see how I'm doing this? 4, 7, 9, 11, 13, 15, 17. 18, 19, 20, 21, 22, 23, 24 times the 4 came up for the class out of, how many times did everyone roll? 10. How many of there are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 18. So that's what, 180 rolls. Everyone see where the 180 is coming from? 18 of us. All right, ready? Let's check it. 24 out of, any closer than when I did it by myself? Am I getting closer? That was about what? 0.4 off, right? Or 0.04. This is about 0.03 off. Everyone agree? So I am getting closer. And guess what? Guess if we did it 100 times. Guess what would happen? It would get closer and closer. The more times we roll the die, the closer and closer it gets to the theoretical probability. So in summary, what am I trying to show you here? The more experiments you do, the closer, the more accurate it gets to the theoretical probability. Yes. Okay, so the more trials we do, the closer and closer the probability will actually get to what it should be. Everyone good there? That's my big thing for today. We all good? Experimental and theoretical. All right. Now let's actually do some experimental probability. I'm skipping over all this and going right to the actual first problem here. Okay, going to the movies. Surveyed people at the theater. I took their age and then counted how many I had of each age range. So there's 13 people who were 0 to 7, 28 who were 8 to 12. Here's what I want to know. Experimental probability, so using the table, I get somebody who's older than 12 but younger than 46. All right? Younger than 12 but older than 46. I'm sorry, older than 12, younger than 46. So on top of my probability is going to go, I need your help. How many people are older than 12 but younger than 46? Based on your table. Anybody find it? How many? 157 out of what always goes on the bottom? Your total, out of the total amount of people. And that's everybody included. Total amount ends up being 254. All right. So there's a 157. And if you want to actually see what that is, you can find the percent of that. That's the percent chance. We okay on how I use the table to find that? Because now I'm going to get crazy with some cards. Can everyone stop, please, what they're doing? Because this is a pretty big moment here. And I'm not, all joking aside, I have to be serious here. We need to go over what a deck of cards consists of. Because people don't play cards anymore, unfortunately. All right. How many cards total do I have? 50. No jokers. 52 cards. Okay, 52 cards. And feel free always to ask. All right. Broken up into 2 colors. 2 colors. Red and black. Yep. Evenly. So how many red and how many black? God. How many cards are red and how many cards are black? Calm down. 26 of each. Everyone agree? Each color is broken down into 2 suits. The red suits. Look at that. I can't draw it well because there's always ice around mine. So, how many of each? They're divided up evenly. All right. Of the black cards, spade, club, a tree, piece of broccoli, whatever you want. How many of each? 13. And now each suit contains what cards? So I got the ace, king, queen, jack, and I'll do 2 through 10. The numbers 2 through 10. All good on our deck of cards? All right, because we're going to have to answer questions now on them. All right. Luckily for us, first we're doing experimental probability. So this big Jimbo here, he records the suit, replaces it in the deck, and here's his results. What's the experimental probability? He drew a heart. How many hearts did he draw? He drew 5 hearts out of how many cards did he end up picking? If you add that up, 25 cards. Yep. So 1 out of 5 shot. Nice job, kids. What's his experimental probability he draws a black card? Experiment. So look at his experiment. How many black cards did he draw? Remember, what's black cards again as far as suits? Clubs and spades. So he drew a total of 16 out of 25 for his black card probability. All right, he did it. Jimbo did another one. Now, please combine his results. Combine his results now. Experimental probability of drawing a black card now when you combine them. So add up all the clubs and the spades now. Where does that leave me? He's got 2 experiments now. He's going to combine the results. How many black cards does he have now? 27. No longer out of 25, but anybody add all of them up? Should be out of 50. Yep. Ooh, now we got to go back here. Go ahead. Did I lose anybody here? Ask me. All it was using the experiment. Now, theoretical of a black card. Who cares what happened here? Theoretical. So go to your deck of cards again. How many black cards are in a deck of cards? 26 out of 52, also known as 1/2. They're either red or black. All right, go back to the experiment. Combine them. Probability you get a heart. How many hearts were picked? From the experiment. Not theoretically, but from the experiment, how many hearts were picked? 11 hearts out of, how many did he draw? Not 52, that's in a deck. 50, 11 out of 50. And what's the theoretical probability you draw a heart now out of a deck? How many hearts did we say there were? 13 hearts out of 52 cards, yep. All right, now it says explain your results. Everyone have a calculator ready. When he did a single trial, go back up to our answers on parts A and B. What was the probability he drew a heart? Go back up. What did we say in part A was the probability, experimental probability he drew a heart? 1 out of 5, right? All right, 1 out of 5. When he did a second one and combined them, what was my probability of getting a heart? 11 out of 50. And then what was the theoretical probability of getting a heart? What should it be? Here's what I need you to do on your calculator right now. Do 1 out of 5 right now. Go ahead, 1 divided by 5. Everyone's getting 0.2. All right, do the combined one, which was 11 out of 50. Everyone do 11 out of 50. And finally, do the theoretical, which was 13 out of what? Guys, what's happening as I went from the single to the combined one? Here's my theoretical 0.25. I got 0.2 as a single trial. 2 trials gave me 0.22. What's happening here? I'm getting closer and closer to the theoretical, the original one. So explain results, and here's what I wanted to show you today. You tell me, the more experiments you do, or the more experiments done. You guys want to finish that for me? The more experiments done, the closer you get to the what probability? The closer you get to the theoretical probability. Will I ever hit it? Probably not, but I'm going to get awfully darn close the more I do. The closer you get to the theoretical probability. Hey, now that you guys got your Chromebooks out, why don't we open up an answer key up on Aspen and get going to the homework, huh? There you go. Dual purpose of your Chromebooks today. Open up today's answer key and get going. Do not pack up until A, you're done, or B, 207 hits.